So let's look at how we solve a system of linear inequalities. So first thing we want to do is graph the corresponding equations. So we're going to change those inequalities to equal signs and graph these two equations. So they're set up in a y equals mx plus b form, so I'll take advantage. So that top one, I have a y-intercept of -3 and a slope of 2, so up 2 and over 1. Do it again. And then grab a straight edge. It's a little bit more important here to have those things line up so that it makes sense when we go, because we're going to try to find points that are not on this line. So having your line look good is helpful. So there's the first one. And so then let's graph the second one. It has a y-intercept of +1 and a slope of +1. So up 1 over 1, up 1 over 1. Do it a couple of times. Now, even though we're doing a super good graph, we're still going to go and find that point of intersection analytically just to make sure. So we can see where they land. Here, let me get my thing back here. We can see where they intersect, but we want to find that point analytically. So we're going to solve this system using either substitution or elimination. I'm going to go ahead and substitute since I have a y equals and a y equals. So I will set the two right sides equal to each other and solve for x. So subtract the x from both sides, add the 3 to both sides. That gives me the x value of 4, which it looks like from my graph. And now I plug this back into either of the original equations to find the y partner. So y equals x plus 1, so 4 plus 1, that's 5. So the point of intersection is the point 4, 5. Yes, I know you could have seen that from the graph, but we need to find it analytically, at least if you're in my class. But now we need to find the x's and y's so that these two inequalities are true. So it's not just going to be that one point, that's where they're equal. Right? Where is it that the greater than or equal to or the less than or equal to hold out for both at the same time? So you'll notice that my plane is now divided up into 4 regions. I need to decide which region to shade. And there are a few ways you can do it. One, you can try to reason. So I need the y's greater than, so above the 2x minus 3 line, and at the same time that are below, right, less than the x plus 1 line. So think about where you're going to shade, get an idea. And then I've done it before, so I know where I'm going to shade. And I'll show you the other way. That is, we need to pick a point that we know is in each of the regions, and we need to test it in the inequality. If we find a point that it's true, then that's the region we're going to shade. And as long as they're both linear, it's just going to be one of the regions. So let's go ahead and check 0, 0. I can see 0, 0, plus remember I know the answer. I can check 0, 0. I can see that it's in that right skinny region that's kind of down below. So let's check it out. So checking the point 0, 0 in the system. So now I'm back to the inequalities. So the equals part has done its job, and I'm not going to pay attention to that anymore. I'm going to work around it. So in the top, is y equals 0, is that greater than or equal to 2 times 0 minus 3? Is 0 greater than or equal to -3? It is. So 0, 0 works in the top equation. Let's see if it works in the second equation. Is y equals 0 less than or equal to 0 plus 1? Is 0 less than or equal to 1? It sure is. So 0, 0 works in the bottom equation as well. Works for both, I should say inequalities, works for both of them, so 0, 0 is in the solution set. That means that all of the points in the region that had 0, 0 is in the solution set as well. So I'll shade that. If you're wondering, well, could it be that there's another region that we should shade as well? Well, sure, you can check. So for instance, right here, I see that 4, 0 is very decidedly over there on the right-hand side of both of the lines. Let's see if the point 4, 0 works here. My guess is no, but we'll check. So check 4, 0 just to make sure. So x goes in for, right, 4 goes in for x and 0 goes in for y. is 0 greater than or equal to 2 times 4 minus 3? Is 0 greater than or equal to, what is that, 8 minus 3, 5? No, it's not. As soon as your point doesn't work for one of them, it won't work for the system. The system has to work together. So no, so right, that region we would not shade. And we didn't.